So I just wanted to talk a little bit about my strain gauge in stop and some of the design decisions that I made, the good ones and the bad ones. So um, the way this works is this is attached to the X carriage, and then this teal piece screws to the nozzle through the center here, and then on the outsides it screws up to this frame piece. And here's a cross-section view. So these are little flexures, and this centerpiece is free to move up and down because there's a gap through here. And then the strain gauge goes on the top of that flexure. Right now I just have one strain gauge in a quarter Wheatstone bridge configuration, and it's very sensitive. So I'm using these strain gauges here. They're only 7 millimeters by 5 millimeters, and they can go right on that surface. And I just have one of them, and if I take a post-it note and cut it in half and run it into the side of the nozzle, partially due to the fact that the nozzle or the hot end's very long, when the post-it note buckles, it's actually enough force to trigger the end stop. So it is pretty sensitive, and that's actually with a very small strain gauge. So with a larger strain gauge, you'd be able to get more sensitivity out of it, and I think a full Wheatstone bridge is more sensitive. It's at least more resistant to like thermal variation and stuff like that, which is good. So I think an ideal design would have either a half bridge with maybe a strain gauge over here and here, or maybe a quarter bridge where maybe I have 4 of these going in all 4 directions. And I think that would maybe improve the sensitivity, because then that would let me stiffen this up, because right now I would say these are a little too thin. This is 1.5 millimeters thick. I 3D printed it out of PLA, but that is a little too flexible, I would say. I'd rather these be thicker and for the whole mechanism to be stiffer, and for the strain gauges to just be a little less sensitive than they are now, and I think that would still work. One other thing, the biggest problem with this is that if I hide this plate here, okay, these flexures are really prone to torsion, so they twist along this axis, and that causes the nozzle to swing back and forth. And I would say it actually has more travel back and forth than it has up and down. So that's the biggest flaw with this design, and I think I can mitigate that by adding a support down here at the nozzle. I could actually take one of these like coil flexure bearings and screw the nozzle in through this, and have that mounted somewhere, braced somewhere, and that would constrain the nozzle tip to just moving up and down, and it would keep it supported left and right and front and back in its motion. And that would prevent the nozzle from having as much vibration side to side. And that would also kind of create, all these spirals would create a little bit of a thermal barrier, a thermal break between the thing it's mounted to and the very hot nozzle. So that's one way I can maybe improve this design. Let's see, one other thing I wanted to talk about is, it also doesn't have a stop here, so the nozzle is free to move both up and down. When you're probing, you only really need it to move up. I saw some discussion on the forum that if you allow it to move down, you can detect extrusion force. I think that one way you can maybe detect extrusion force without allowing the nozzle to move down would be to do something kind of similar to this, have like maybe a second flexure with a second strain gauge up higher. So if I go back to my cross-section view, if you imagine, let's see, get a pin here, if there was another flexure out here and a tab with a thick piece, and this was screwed down over here, and you had a strain gauge on this surface, whenever the extruder pushes filament down, it'll create an equal and opposite force up on the extruder here, which will deflect this up, and it can measure that and having the extruder actually move up and down rather than having the hot end move up and down. So but yeah, the hot end could still move up for detecting probes, but wouldn't move down to detect the extrusion force. The extruder would just move up for that. That might be better for keeping the nozzle a little more constrained. That's just one idea that I had. Let's see, what else? Yeah, I also wanted to compare two different strain gauges. So this is the one that I used. It was 7 millimeters by 5 millimeters, and it has about 30 lines back and forth across this distance here of about 3.8 millimeters. This, I did some rough measurements. This is about 23.7 millimeters with about 78 lines. So, approximately 2 times as many lines, but way more than twice as long. So the density of this is a lot less than the density of this. So this style of strain gauge should be a little more sensitive. So we may want to go with strain gauges more like this than these integrated PCB ones, although I do like the simplicity of these. Perhaps, since these are so sensitive, perhaps this is sensitive enough, and it sure would be easier to assemble because these strain gauges were really fragile. I had a hard time getting the solder to actually stick to these solder pads. It almost seemed like there was like an enamel layer over the whole thing or something, because it seemed like the solder really wanted to just bead up and not stick to these. And I actually melted a few just trying to get it to stick. So that was one problem I had with actually mounting this strain gauge in there. But yeah, after I did get the strain gauge mounted and super glued in, I covered the whole thing with this silicone conformal coating. It's kind of a brush-on silicone, and I thought that would help reinforce everything. It could maybe add some strain relief to the wires by kind of gluing them down, and I think that helped. This thing is also so sensitive that if I bump the wires that come off of this, it can also trigger. So even though this is super glued down and these things are not even really in the grid, the strain grid, still just bumping the wire that's soldered to this pad actually creates enough force to trigger for this to sense it. And I think that's probably because when I push on the wire, it's deflecting this plastic here, and that's what's actually being picked up by the strain gauge. So it is very sensitive, which is good because it'll let us make things more rigid and more stiff and still be able to detect it due to that sensitivity. So yeah, I just wanted to kind of talk about some of the pros and cons of this design, things that I could do better. Hopefully that sparks some interesting conversation.